Now let's take what we just did in the last video and go backwards. So instead of taking a single logarithm and expanding it, we're going to take some expanded logarithms and write them as single logarithms. So I don't know if you paid attention when I was doing these examples here. One of the last steps I did was to move those exponents to the front as coefficient products. So that means we're going to start there and start by taking those coefficient products and writing them as exponents. So that little 2 that's in front of my logarithm will become a squared on the x. And this -3, or I could just say it's a +3, would become a power here. Then don't forget that this is a negative, which means it's going to be division in the overall problem. So that gives us, I'm just going to write this out, what I just did. So log x squared minus log x minus 1 cubed. So I've moved those coefficients as back on as powers. So now I have subtraction, and subtraction is the quotient, it's division. So this is going to be dividing from that, right? So I have log, and then in the numerator is going to be x squared, and in the denominator is going to be x minus 1 cubed. So that is all part of the argument of this logarithm, which is base 10 because there's no number there. So I have written my expanded logarithm as a single logarithm now, and I've completed the instructions of the example, writing it as a single logarithm. Okay, let's look at number 2. Again, we're going to move these powers to the front. There's only that one that I can see here. So this will be natural log u to the 4th minus natural log 5u plus natural log 1 over u. Okay, so now I have subtraction, which means division. So I have natural log, and u to the 4th is positive. It's a positive logarithm. So that's going to be in the numerator. And then this one's a negative. It's subtracting in the overall problem. So it's going to be a division piece right there, right? And then we have a plus, which would be another multiplication piece. But they've really made this an interesting problem because the addition would mean multiplication, which would mean numerator, but it's already a fraction going in the numerator, which is a little bit weird. Now we just have all this algebra to simplify. So we have u to the 4th times 1 over u. Isn't that the same thing as u to the 4th divided by u? That's just the numerator, which turns that into u to the 3rd. And then that is over 5u. But if we have a 5u in the denominator, doesn't that mean that one of those u's can cancel with one of those? So I'm pretty sure my overall answer, if I haven't lost u yet, is u squared over 5, because my u to the 4th times 1 over u turns into u to the 3rd, and then my u to the 3rd divided by 5u turns into u squared over 5. So here is my simplified single logarithm answer. Let's go ahead and use some of this stuff. I know sometimes I hurry from one to another, but I know, as you know, the power of these videos is that you can pause them at any point and go back and look more slowly at what I did or at my work or whatever. Okay, we're going to use properties we've learned to solve logarithmic equations. Don't forget to check for extraneous solutions. So on this side of my problem, I have 2 logarithms. Wouldn't it be nice if this was just one single logarithm? So we've learned how to do that as long as the bases are the same. So base 10, that's easy. That means I can rewrite this as log of x over 2 because it's subtraction, which indicates division since logarithms are exponents. Now I just have a single logarithm equal to a number. Now we just default to what we've learned about logarithms, which is the base of the logarithm to the value of the logarithm, or its power, is equal to the argument, right? Well, what is the base of this one? There's no base written there. That means it's base 10. So if the base of our logarithm is 10, we can change this to exponential form by rewriting it as 10 to the first power. Why to the first power? Because the value of the logarithm is 1. So 1 is the exponent. So that is going to be equal to our argument, x over 2. Now we have a simple cross multiplication type of problem. We can do 2 times 10, which is 20, and the answer should be x equals 20. We might want to check our work, so plug it back in. First of all, we can do the log of 20 because it's not a negative number. That's the first thing to note, that that's good. So then if we check this, we end up with the log of 20 subtract the log of 2. Well, doesn't that mean the same thing as the log of 20 divided by 2, which is the log of 10? And since it's base 10, the log base 10 of 10 is in fact 1. And that checks out. That one wasn't too bad. Let's look at our last example here, number 13. Again, we're going to solve our logarithm by writing these as a single logarithm and then maybe changing this to exponential form. So they're both base 2. So to write this as a single logarithm, I have to keep the base 2. Then addition means multiplication. So it's going to be x times x minus 1. The addition of logarithms is the multiplication of the exponentials. So we're multiplying those arguments together to combine it into a single logarithm. Okay, so that gives us log base 2 of x squared minus x. Now, of course, this still all equals 1. Well, we have a single logarithm here equal to a value, and that value is the exponent, right? The base is 2. So all we need to do is rewrite this as an exponential. 2 to the first power, base 2, exponent 1, equals x squared minus x. We have a quadratic to solve. Hopefully we've gotten pretty good at these by now. So I'm going to get everything on one side, subtract that 2 over there, and then that means I'll have 0 on the left, but I'm just going to go ahead and put the 0 on the right. Factor this, x minus 2, x plus 1. That gives me possible solutions of x equals 2 or x equals negative 1. Don't forget to check your answers. So if I go back to my original problem, and I try checking log base 2 of 2 plus log base 2 of 2 minus 1, then I get log base 2 of 2, which is 1, and I get log base 2 of 1, which is 0. 1 plus 0 equals 1, so that one's good. Let's try the other one. So log base 2 of, oh, I see a problem right there. Do you see the same problem I see? So I plug in that answer negative 1, and I don't really even want to go any further because I can't do the logarithm of a negative. This is undefined. And so that means negative 1 is an extraneous solution. It happened because of the properties we used to solve the problem. So we really did do the problem right, it's just that we don't get, that answer doesn't work. So our solution to this problem is x equals 2. And that's the only solution because x equals negative 1 is undefined.